Game is
And well, there's
over.
some stuff coming out of the Antarctic lately about the sea
Very soon
ice.
we are in water.
That's, well, it's pretty big news.
Oh, yeah, for sure.
And we're going to, dive into that today, really try and get a handle on what's going on down there.
Definitely. And it's not just about some like far off frozen place. What's happening in the Antarctic, it affects everyone, the whole planet, really.
Yeah.
So understanding this, it kind of gives you a glimpse into where we're all headed. You know what I mean?
Yeah, exactly. We've got all the latest data from the European Union's Copernicus Marine Service. And we've also got, well, you, of course, to help us make sense of it all.
Happy to be here.
Really, our mission here, it's to cut through all the noise, right? To give everyone the most important info about this climate thing, but without, getting too bogged down in the weeds.
Like, it can get pretty complicated, yeah.
Totally. So when we talk about Antarctic sea ice, we're talking about, well, it's much more than just a bunch of ice.
Oh, yeah, way more.
Yeah.
It's a huge part of the whole global system, like the ecosystem, and it's a habitat for all sorts of creatures, and it helps drive the ocean currents, like a giant engine.
Right, like a crucial part of the machinery.
Exactly. And it acts like a global thermostat bouncing sunlight back into space. So it really does a lot.
Okay, so let's jump into the news, the data, the reason we're all here. It seems like things have hit, a pretty alarming low point.
Yeah, so the latest from Copernicus Marine Service, they say that on February 25th this year, the Antarctic sea ice, it hit its lowest point for the year.
Okay.
And that minimum, it was 722,000 square miles.
Whoa, hold on. That's a big number.
It is, yeah, about 1.87 million square kilometers.
Okay, but what does that actually mean?
It's
like
a
in the
very
grand
big
scheme of
number.
things, how bad is that?
Right. So to put it in context, that puts it as the 7th lowest we've ever recorded.
Oh.
And what's maybe even more concerning is that it's the same as the low point we saw in 2024, just last year. Plus, it's 8% lower than the average we saw between 1993 and 2010. So that really shows how much things have changed,
Yeah. And this isn't just a one-off, like a fluke year, right?
No, not at all. Copernicus, they've been tracking this, and they've seen record lows every year since 2017.
Every year, wow.
Yep. That steady downward trend, that's what's really getting scientists
Since
worried.
2017,
Yeah, that makes sense. And I mean, the
Record
main
lows.
culprit here, the thing everyone's pointing to, is global warming,
It's over.
right?
Yeah, pretty much.
Right.
The vast majority of scientists agree that the rising global temperatures, which are mostly caused by us, humans, things like burning fossil fuels, that's the main driver behind all this ice loss.
Yeah, and we actually have a quote from Claire Young, a researcher at Australian National University.
So what to be
She
done?
had some pretty
Commented.
strong words about this.
Oh, yeah, she called it a stark reminder of the unprecedented and serious climate changes affecting our planet. And she really hammered home how much lower the ice coverage is compared to what we used to see, historically.
Yeah, that's pretty sobering. So we often hear about scientists using all these maps and satellite images to track all this. Can you walk us through how that works?
Sure. So Copernicus, they use what's called radiation data and visible satellite imagery. Basically, it's like having eyes in the sky that are always watching the ice.
Okay.
The radiation data, that helps measure things like the temperature of the ice and how much light it gives off, which tells us about what kind of ice it is and how much there is. And the visible imagery, well, that's just pictures, snapshots of what the ice coverage actually looks like. Both of these together, that gives them a really complete picture of what's going on.
And so what do these visuals actually show us? I mean, beyond just the numbers shrinking, what does the ice loss look like on these maps?
Well, they show pretty clearly that there's a dramatic loss of ice all around Antarctica. But what's interesting, they also show that it's not melting evenly everywhere. Scientists are calling it uneven melting.
Uneven melting, huh?
Oh.
So some areas are holding up better than others.
Oh.
Exactly. The data shows that places like the Weddell Sea, the Bellingshausen Sea,
How like
Wilkes
that?
Land, and Amory Land, they haven't seen as much melting as other parts of Antarctica.
Interesting.
Yeah, and scientists are looking into why that is. They're thinking it might have to do with things like ocean currents and wind patterns in those areas.
Right. So we keep saying sea ice extent. Just to be clear, for anyone listening who might not be totally familiar with that term, can we define it? What does it actually mean?
Of course. Sea ice extent. It's basically the total area of the ocean around Antarctica that's covered by at least 15% ice. So it's like if you took a map and colored in all the parts of the ocean that meet that 15% threshold.
Okay.
Important to note, this doesn't include the huge ice sheets that are on the land itself.
Right, so we're just talking about the ice that's floating on the water. And of
Exactly.
course that changes with the seasons, right? Grows in the winter, shrinks in the summer.
Exactly. During the southern hemisphere's winter, which is July to September, the sea ice gets way bigger, reaches its maximum extent. Then when summer rolls around, December to February, a lot of it melts, and that's when it hits its minimum, the low point that we were talking about earlier.
So by tracking that yearly minimum, we get a good idea of the long-term trend.
Exactly.
Okay, so we've got sea ice extent, but then there's also this other measurement, sea ice volume. Can you explain the difference and why is it important?
Sure. Think of it this way. If sea ice extent tells you how big a frozen lake is, sea ice volume tells you how thick the ice is.
Okay.
So it takes into account not just the area covered by ice, but also the average thickness. So extent tells us how far the ice spreads, and volume tells us how much ice there actually is.
Gotcha. And what's the news on sea ice volume? As bad as the extent.
Okay.
Sadly, yeah. The latest shows that on March 5th, 2025, the Antarctic sea ice volume, it also hit a near record low for the year. It went down to just 247 cubic miles. That's 1,030 cubic kilometers.
Oh.
And to put that in perspective, that's a 56% drop compared to the long-term average.
56%. Yikes.
Yeah, it's a huge amount of ice that's gone.
And I guess the point here is, even if the ice still covers a decent area, if it's thinner, it's way more likely to melt away in the future. Right?
Exactly. Higher temperatures, they don't just shrink the ice, they also make it thinner. And that thinner ice, it's much more fragile, much easier to melt, even with small temperature increases.
Okay, so less ice overall, and
Temperatures
the
are
ice that's left is
rising.
weaker.
Yeah.
Now let's talk about why this matters so much for the whole planet. We mentioned it briefly, but can you really explain this albedo effect?
Sure. Albedo, it basically means how reflective something is. So white things, like fresh snow and ice, they have a high albedo, meaning they bounce most of the sunlight that hits them back into space. And that helps keep the planet cool. Think of it like wearing a white shirt on a hot day. It reflects the heat.
Right, right.
But when that ice melts, it exposes the darker ocean underneath. And dark surfaces, they have a low albedo. They absorb way more sunlight. So that absorbed energy, it warms up the ocean water, which then makes more ice melt, which exposes more dark ocean, and so on. It's a vicious cycle.
Yeah, like a snowball effect, but with melting.
Yeah,
Okay.
exactly.
Yeah.
And Peter Dines, the managing director of MIR, he had a pretty strong warning about this. He said, losing this reflectivity because of the melting ice, it can have really serious consequences for global temperatures. And he stressed that this isn't just an Antarctic problem, it affects the whole planet's energy balance and can make global warming even worse.
Right, so it's not just about the ice itself, it's about the knock-on effects for the whole planet's temperature.
Exactly.
And it's not just about reflecting sunlight either, right? The Antarctic sea ice, it's also a super important habitat for a lot of animals.
Absolutely. It's crucial for seals, walruses, all sorts of creatures. They use it for resting, breeding, hunting, everything.
And I imagine the shrinking ice is putting a huge strain on them, making it harder to survive.
Definitely. Less ice means less space for them to live, less food to find. It's really tough on them.
And it's not just the big animals that are affected, right? There are impacts further down the
It's
food
really
chain
tough.
too, like with the krill.
Oh yeah, the krill are super important. They're like the base of the food web down there, and tons of animals rely on them, from whales to penguins. And with the warming, we're already seeing the krill moving further south.
And what does that mean for the other animals?
Well, if the krill move, the animals that eat them have to move too, or they'll starve. And that disrupts the whole food chain, which can have ripple effects throughout the entire ecosystem.
So it's all interconnected as usual. Changes in one place can affect everything else. And unfortunately, this isn't just an Antarctic problem, right? We're seeing similar things happening in the Arctic.
Yeah, that's a really important point. While we've been focusing on the Antarctic, it's critical to remember that the Arctic is also experiencing record low ice levels.
What's it looking like up there?
As of March 22nd, 2025, the Arctic sea ice extent hit
Oh my
5.53 million square miles. That's the lowest it's ever been in the 47 years we've been tracking it with satellites.
Wow, so
Huge.
both poles are seeing huge ice losses.
It's
Really
a
drives
collapse.
home the global scale of this, huh?
Yeah, it's a clear signal that climate change is happening all over the planet, and the effects are getting
Do you
stronger.
believe in climate
And
change?
as this ice
Commented.
keeps melting at both poles, the consequences for the ecosystems, the wildlife, and even for us humans, they're just going to keep getting worse, right?
That's the scary part. It's not just about abstract scientific data. This is about real threats to the planet and everyone on it, which is why we need to take action on climate
Nobody
change.
cares. Nobody.
Like now.
So to sum it all up for you, for our listeners, here's what we've learned about the Antarctic sea ice.
Poof.
It's at near record lows, both in how much area it covers and how thick it is. And the main reason for this is global warming. This loss of ice, it affects everything, from how much sunlight the planet reflects to the survival of entire ecosystems. And unfortunately, the same thing is happening in the Arctic. So understanding these changes, it's essential if you want to really grasp what's happening to our planet right now.
It's all connected, and these changes at the poles, they have ripple effects everywhere.
And on that note, I mean, it makes you wonder what other seemingly unrelated changes might be tied to this rapid ice loss. What other dominoes are starting to fall in our planet's delicate systems? What other questions does this raise for you about the
That's right.
future of our world?
That's the big question, isn't it?
It is, and it's one we all need to be thinking about.
Absolutely.
All right, well, that's all the time we have for today. Thanks for listening, and we'll see you next
Thanks.
time.
See you then.
Bye.
Bye.